while we're getting this up, I've seen quite a few in the halls, and you guys mostly remember me. Last year, we were a team of 1. This year we have significantly more participation. There's 4 of us and 4 more, and then a couple we left at home. So 1,000% increase from last year. We're quite happy with that. So with that, we're going to go ahead and get started.
All right, we first met back in September, and we made some rough sketches, some brainstorming ideas of what direction we wanted to take with our tower. We're going to list a few of our major points. We wanted to make sure our tower was symmetrical so that loading could be placed and be equivalent from either direction. We wanted to have a wide base to increase stability, and we wanted to have unique architecture, stability, revenue, and architecture. However, we had some major flaws. The optimal floor space leads to awkward geometry in the footprints, and this was hard to construct. Okay, sorry. Is it not on? All right. So, upon finding out the rule change that floor area could exceed the floor area of the floor below it, we decided to modify our design. And we first went with the box on stilts to optimize the high rent areas. However, this was boring. And so we modified that structure into something a little more appealing.
So our structure consists of 3 floor plans. The first floor plan runs all the way up through the structure. So it's hexagonal pillars. And this alternates between this floor plan and this X floor plan for the first half. And what this does is it provides a place for us to attach the weights at the lower half, and then as we go up to optimize our higher floor area, we have this, it's pretty much a box with an inverse bay area cut out of each side. So the trapezoid is cut out. And the final project looks something like that. As you can see, the X structures provide a place. The space is alternating between the pillars and the X floors. We have a space where you can go outside, kind of a balcony area. You could have gardens there, restaurants. Very appealing to look at it.
Another part of this was the analysis. For the analysis, we decided to try and use ETAB. This was an exciting experience for all of us because we had never used it before, and we were able to, it was pretty easy to use. We were able to put our structure in and start to get results. However, as we used the results, initially the acceleration seemed unreasonably high, greater than 3 Gs. And so our plan was, as we were to construct our model, we would be able to test our model and help our model become more in line, or help our model become more in line with our tower as we constructed it. And we also were able to run analysis, and here's a video of it running the second motion, and so you can see it kind of shaking. We thought that was kind of cool.
Okay, we have a small confession to make. At BYU, we don't actually have a shake table. I know many of you do, and that we're jealous of you. But so we had to come up with some creative resources. We planned on doing just a sinusoidal analysis on a basic shake table, which vibrates back and forth at a constant frequency. And we were going to calibrate our ETABS model based on our test results. And then once the material properties were input, then we hoped to have a really good output. Unfortunately, last week our engineering building was shut down for 3 days because a wannabe electrical engineer put a drill bit through the main power line. So, gas leaks, etc. Basically, to make a long story short, we don't really have predictions, except just coming up with them based on last year's performance, stuff like that. So that's our little disclosure. But we did have fun constructing it. A few stitches and a whole lot of fun. So we have a short video here of how we built the structure. We used our trusted styrofoam mold. We built some 90-degree angle molds, put pins in to hold the pieces in place while they were drying, so that everything would be within tolerance. And then we glued the columns up and down. So we have a whole bunch of angles. We combined the 2 angles to make a hexagon with other pieces. It's kind of hard to explain. And we took those out. We used a bandsaw to trim everything so that we had nice joints, nice clean surfaces, because it's really hard to measure to a 100th of an inch. And then we made these 4 hexagons, put them in another mold. The styrofoam is great, and whatever with it. I highly recommend it for any teams that are wondering what to do. And then we attached the internal bracing. Up here in a second you'll see our X-floor bracing, which was really complicated. You have to notch the pieces, put them in. That was a little hard, but we made do. And then also putting our cross bracing up the center. Took nice feminine hands, you'll see here in a second, because it's really hard to get to. 2 inches pretty tight. But as you can see, here we attached it to the base plate. We extended the columns through the bottom to give it a nice secure foundation attachment point. And then last night, upstairs, here's our tower. We were quite pleased with it, and have one concluding remark that we think you'll like.
So, in conclusion, we have balsa wood, $85. Copay, 8 stitches, $15. Boarding pass for inanimate object, $150. Picture with tower in airplane cockpit.
Any questions?